So continuing on with aluminum. So how is aluminum made? How was it made back then and how is it made today? So here we have aluminum. Aluminum is Al2O3. It's also ruby and sapphire. Whenever you encounter a ruby gemstone or a sapphire gemstone, you're actually looking at aluminum and oxygen. So it's basically just a rusty form of aluminum that looks shiny and polished jewelry. So aluminum occurs in igneous rocks, chiefly as aluminosilicates, in feldsparts and feldspathoids, and micas, in the soil derived from them as clay, upon further weathering as bauxite and iron-rich laterite. Bauxite, a mixture of hydrated aluminum oxides, Al2O3 and various other forms, is the principal aluminum ore. Crystalline aluminum oxide, emery or corundum, which occurs in a few igneous rocks, is mined as a natural abrasive or in its finer varieties as rubies and sapphires, seen here. Aluminum is present in gemstones as topaz, garnet, and chrysoberyl. Of the many other aluminum minerals, aluna and cryolite have some commercial importance. So crude aluminum was isolated in 1825 by Danish physicist Hans Christian Ørsted by reducing aluminum chloride with potassium amalgam. So the aluminum smelting process, how it was made back then and today. So although there are several methods of producing aluminum, only one is used commercially. The Deville process, which involves direct reaction of metallic sodium with aluminum chloride, was the basis of aluminum production in the late 19th century. But it has been abandoned in the favor of the more economical electrolytic process. Here we have the Deville process. The exact process involves using sodium and combining it with aluminum chloride to produce sodium chloride and aluminum. That's how you get aluminum. Here's the balance equation. It's 3 moles of sodium combined with 1 mole of aluminum trichloride, which is 1 atom of aluminum combined to 3 atoms of chlorine, and 3 moles of sodium chloride, which consists of 1 atom of sodium and 1 atom of chlorine, and 1 mole of aluminum. That's the balanced equation ratio. And that was the 19th century Deville process. So a quick reminder, aluminum is also a main ingredient in concrete and ceramic. So what process do we use today? So the great attraction of carbothermic smelting is the possibility of bypassing alumina refining and of starting with lower grade ores than bauxite and lower grade carbon than petroleum coke. Despite many years of intensive research, however, no economic competitor has been found for the Beyer-Heroult approach. Although unchanged in principle, the Hall-Heroult smelting process of today differs greatly in scale and detail from the original process. Modern technology has produced substantial improvements in equipment and materials and it has lowered final costs. So the reason that we switched to different technologies is because the Beyer-Heroult approach involves better equipment, better materials, and lower final costs. So let's learn about that. So in a modern smelter, alumina is dissolved in reduction pots, deep rectangular steel shells lined with carbon that are filled with a molten cryolite consisting mostly of a compound of sodium, aluminum, and fluorine called cryolite. So here we have that description. Here we have the molten cryolite alumina, the molten aluminum, the graphite cathode, the ceramic, the steel casing, the insulation, and the ground. Here's the bus bar to the previous cell. Here's the fused coke anode. Here's the steel spider. Here's the hydrogen fluoride particular exhaust. Here's the fume hood. And here's the bus bar to next cell because again, they're cells. They're all reduction pots. And here's the electricity. And here's the positive and the negative. And here's the siphon to retrieve the aluminum. Aluminum is siphoned off. And here's how aluminum looks like. It consists of 13 electrons, 3 valence electrons, and its element number 13. Here's aluminum being poured. And here we have cryolite. The formula for cryolite is Na3AlF6. Again, consists of the elements sodium, aluminum, fluorine. And here we have another demonstration of how aluminum is processed. By means of carbon anodes, direct current is passed through the electrolyte to a carbon cathode lining at the bottom of the cell. A crust forms on the surface of the molten bath. Alumina is added on top of this crust where it is preheated by the heat of the cell, about 950 degrees Celsius or 1700 degrees Fahrenheit. And it's absorbed moisture driven off. Periodically, the crust is broken and the alumina is fed into the bath. In newer cells, the alumina is fed directly into the molten bath by means of automated feeders. So continuing on. The results of electrolysis are the deposition of molten aluminum at the bottom of the cell, seen here. Here's molten aluminum at the bottom of the cell, and here's molten aluminum at the bottom of the cell. And here's molten aluminum at the bottom of the cell. And here's molten aluminum at the bottom of the cell. And the evolution of carbon dioxide on the carbon anode. About 450 grams or 1 pound of carbon are consumed for every kilogram or 2.2 pounds of aluminum produced. About 2 kilograms of alumina are consumed for each kilogram of aluminum produced. So the smelting process is continuous. Additional alumina is added to the bath periodically to replace that consumed by reduction. Heat generated by the electric current maintains the bath in a molten condition till the fresh alumina dissolves. Periodically, molten alumina is siphoned off. Because some of the fluoride from the cryolite electrolyte is lost in the process, aluminum fluoride is added as needed to restore the chemical composition of the bath. A bath with an excess of aluminum fluoride provides maximum efficiency. So here we have aluminum fluoride. The chemical formula for aluminum fluoride is AlF3. Aluminum fluoride refers to inorganic compounds with the formula AlF3 times XH2O. They are all colorless solids. Anhydrous AlF3 is used in the production of aluminum metal. Several occur as minerals. According to Wikipedia, its formula is AlF3. Its molar mass is 83.9767 grams per mole. Its mole is 83.98 grams per mole, according to Socratic.org. So, which is a fluoride form of aluminum? Aluminum fluoride refers to the inorganic compounds with the formula AlF3 times XH2O. They are all colorless solids. Anhydrous AlF3 is used in the production of aluminum metal. And colorless solids just means that the powder form that it creates is white. So continuing on, molten aluminum is siphoned from cells in large crucibles. From there, the metal may be poured directly into molds to produce foundry ingot. It may be transferred to holding furnaces for further refining or for alloying with other metals or both to form fabricating ingot. As it comes from the cell, primary aluminum is about 99.8% pure. Automation and computer control have a marked effect on smelter operations. The most modern reduction facilities use fully mechanized carbon plants and computer control for monitoring and automating pot line operations. So how and where is aluminum extracted? So aluminum, Al, also spelled aluminium, chemical element, a lightweight silvery white metal of main group 13, 3A or boron group of the periodic table. Aluminum is the most abundant metallic element in the Earth's crust and the most widely used non-ferrous metal, which means that it's not iron. Because of its chemical activity, aluminum never occurs in the metallic form in nature. Aluminum is found on Earth and it's very common. Because of its chemical activity though, aluminum never occurs in the metallic form in nature, but its compounds are present to a greater or lesser extent in almost all rocks, vegetation, and animals. Vegetation is an assemblage of plant species and the ground cover they provide. It is a general term without specific reference to the particular taxa, lifeform, structure, spatial extent, or any other specific botanical or geographical characteristics according to Wikipedia. Aluminum is concentrated in the outer 16 kilometers or 10 miles of the Earth's crust, of which it constitutes about 8% by weight. It is exceeded in amount only by oxygen and silicon. The name aluminum is derived from the Latin word aluminum, used to describe potash aluminum or aluminum potassium sulfate, seen here, consisting of the elements potassium, aluminum, sulfur, hydrogen, and oxygen. Here's aluminum potassium sulfate. That concludes the 3-part series of Aluminum Explained. So other than that, thank you everyone for watching. I hope you learned about how aluminum is made. Let's continue with the element radon in the next video. Other than that, have a great one.